agreed to come over, I decided rather than bring a bunch of equipment over and so forth, that this would be a potpourri night and just talk about various things. First of all, I just got CQ magazine just before, about a half hour before we left home, and there's a little item in there that Heathkit is going to go back in business, which I hadn't heard about. Some of you guys had, and it's going to be interesting to see what products they have. And there was an article in there on a statement which fits right in with what I wanted to start with. Some time back, I talked about sunspot activity and so forth, and you guys are all familiar to a greater or lesser extent that it goes through an 11-year cycle. So I'll start with 1958, and 1958 was the highest sunspot activity in history. And as the sunspot activity goes up, MUF, maximum usable frequency, goes up. And the entire summer of 1958, FM broadcast in the United States, 88 to 108, was heard in Europe all summer long. The high, as I say, was the highest one. This one backs down, and 47 was the one previous to that. And we usually had 7 years going down and 4 years coming up. Over here, we just couldn't get started, and this thing's finally going up. As you remember from what's happened the last few years, serious scientists, and including one that I quoted or read about tonight, serious solar scientists predicted during this period in here that sunspots were a thing of the past, and that we were heading into a new ice age. This kind of counter the world heating problem, but so I don't know what this is all got to do with this, but we're finally up, and now they say that this is going to be a little dinky sunspot peak. But 10 meters is open. It's been open all week, and Marv has worked Europe and Australia and so forth, and Steve worked Couch on 10 meters.
They got Maryville this morning.
10 meters has been pumping all week. And I've heard it in Europe. I haven't stayed around the evenings to check it on the Pacific area. But it is opening up a little bit, but 6 has not been open. I haven't caught it open. And I'll mention 6 a little later here.
I worked Valpo this afternoon with my cell phone.
Oh. At any rate, what I wanted to do with here, 1942, 43, we were in World War II. And in around 1943, the United States or the Allies got their butt beat in North Africa by General Rommel of the Germans, and he was a tank commander, tank expert, and he just about drove the Allies back into the Mediterranean seas, but he pulled a typical military boner. He outran his supply, and his tanks ran out of fuel, and the Americans were able to escape out of there. And at any rate, we were at a low spot here. The MUF is not going to get up very high. Tanks, because of the distance they have to work on the terrain, they've settled on the 20 to 30, 50, 60, 70 megacycle range. If you look at any pictures of tanks, you'll see antennas about 5, 6, 7 feet long. And at any rate, during the lull of Rommel backing up, refueling and retraining, the story goes, I have never seen it in any official publications, but I have read it several times, that there was a little island off the coast of New England that they were able to hear in the 40, 50, 60 megacycle range and listened to Rommel training his troops for a new tank battle. And the American then copied all this, used interpreters, and they then trained to counteract his, and we beat his butt and drove him back into Egypt and so forth, and won the Battle of North Africa finally. But well, there's been a lot of predictions what would happen if we had lost the first Battle of North Africa. The war might have been a lot different than what it was. Why this was possible or why they had a path from North Africa into this little island off of New England, you bring your own stories to it. So any rate, they predict that this sunspot cycle, the sunspot peak that we are in, is going to be a very small one, and the MUF won't get up very high, but it's getting up over 10 meters, and that's what we're interested in, is for DXing and so forth. I'd like to see it up over 6 meters and whatnot. And any rate, as I say, I just got some odds and ends here, and let's start out with a coil. And this one has 21.1 microhenries. And if we put a 1200 picofarad capacitor across that, it will resonate at 1,000 kilohertz. And 31.1 is probably 30, 40, 50 turns of 2-inch diameter and so on. So let's work with your brain a little bit. Let's take pardon, I gotta look at my notes. Let's take 8 microhenries of that coil and separate it from the coil. And 8 microhenries of inductance on that 1200 picofarad. Then we have 13.1 microhenries left over. I'd like to resonate that coil, that 13.1, I'd like to resonate that to 1000 kc again. It's going to take 1934, I'll do it down here because I want, it's going to take 1934 picofarads to resonate that 13.1 microhenries, which we reduce the inductance, we have to increase the capacity. Where else could I get 1934 picofarads to resonate that 13.1? Playing around your brain here a little bit.
AES. They sell it.
Right there. Let's connect this back to that coil, and isn't it resonant again? And this thing here is equal to that. You say, that can't be. Well, it is. You put a coil in series with a capacitor, and you increase the capacity. Strange as it may seem, I'll leave Marv to do the mathematics for you at the next meeting. But
He didn't bring his slide rule today.
Well,
I gotta find my slide rule.
he's got a month to figure it out.
I gotta find my slide rule.
Hey, Marv, I can help you with that wool faucet. I learned that from you.
Should have told me I would have brought my picket tonight.
you see the guys arguing on the tech thing about the little slide rules and so forth. Simerson, he could never keep track of the decimal point. Simerson couldn't keep track of anything. I'm kind of broadcast oriented in some respects, and but from a ham standpoint, if we go to 80 meters or 160 meters, you're getting into the same techniques that we use in AM broadcasting. It's just lower in frequency. And from 40 meters is kind of a crossover point, but you go from 20 meters on up, we start thinking of antennas that are matched, 52 ohm feed, coax, and so on. 80 meters and 160, we're using random wires and long wire antennas and open wire feed line and verticals, working against ground. Of course, the vertical is the AM broadcast thing. But any of you that have worked, that mess with 160, you know that we're into this kind of stuff. We got a lot of capacity. And variable capacitors, what, your 300, 350 picofarads is about the maximum on variable capacitors. And so in broadcast transmitters and antenna tuners, it is a rare case where we ever use variable capacitors. We use a fixed capacitor and put a variable rotary coil or a tap coil in series with it. Typical capacitors that we use are fixed jobs like this. This is an F series, this is an F1, this is an F2. This happens to be 100 picofarads, and it's rated at 2 amps. So we can put that in a tank circuit or an antenna matching network. This one is 0.004 and is rated at 13 amperes. A lot of current in these. But if we get up into the 5 and 10, 50 kilowatt transmitters, we got to go much bigger than these. Boy, I've been fighting a cold, and
Bottle of junk.
so at any rate,
Stoli.
carrying on with this concept up here, here's the typical capacitor that we have to accept its capacitance, and in order to tune it in a tune circuit or an antenna matching network or so forth, we would put a coil in series with it and then tap it, and if it's going to be in an antenna tuner or even in the RF section of the transmitter, we wouldn't use necessarily rotary coils. We'd use a fixed coil. Of course, with this kind of power, we're not going to use this little coil. This is we're going to use a edge-wound coil with clamps on it and so forth. But there's a variable capacitor that we would use in, say, broadcast transmitters and so on. And along that line, we're going out to the tower and put in a matching network, and say we put a T network in. And we, well, this one, here's the antenna resistance and here's the line resistance. We start out with, first of all, if we got any reactance in the antenna, we would tune that out and get rid of it one way or another. So we got a pure resistance here. So this X3, in fact, back up a moment, if we make this network have 90 degrees of phase shift, then X1, X2, and X3 are the same, and equal to the square root of RL times RA. That gives us the reactance that we need for those components. That's for a 90-degree phase shift. We have equations for this T network that will give us all kinds of shift between here and here, and this we would be using in directional arrays to give a particular phase shift, plus the phase shift in the coax and so on. And we come up that we have to have, say, 71.5 degrees shift in this network. Lagging, we would use this network. If we needed leading, we would put capacitors here and inductance here and so on. But if we don't need a particular phase shift, we just settle for 90 degrees because it's easy to calculate and so forth. We come up with this. Let's say that we run across a diagram of a system that is directional, and they have to have an exact capacitance here. Then we will see a situation where they will have a rotary or a tap coil in here. Looking at that diagram, you say, gee, they're using a series resonance circuit from the center tap to ground. Why would they use series resonance? When you get into AM diagrams, you see all of these variable coils in series with capacitors, and they are not series resonant. The coils are tuning the capacitor to get the right what do I want to say? Right X sub C. Okay. Another situation of interest, just to again play with your mind a little bit. With the situation that you are all familiar with, if you work high frequency, if you work 80 and 40 and 160, well, even 20, because we have a difference in night and day. AM frequencies up to 1600, 1700 kc. They are very predictable from one day to the next, that you get farther out as soon as the sun goes down and so on. And so we have a category of stations that are full-time, like WLS and WGN, and then we have daytimers only, because they would be, if they stayed on at night, they would be interfering with those clear channel or full-time stations. So at any rate, the daytimer onlys have a problem, or had a problem, that, gee, just like a station that I built in Valpo, daytimer, in December and January, we didn't come on the air in the morning until I think it was 7:15 or 7:45. I forget the hours on that, but you're on the air to supposedly provide a public service, and what the hell kind of a service are you providing to the parents that try to get their kids off to school? If you come on the air at 7:15 and the school bus was picking the kids up at 6:30, then they call off the school, and they've been standing out there in the snowdrift for 45 minutes and find out there's no school. So the Daytimers Association, after years of pressure on the FCC, they finally came up with what they called a PSRA, pre-sunrise authorization, PSRA. And the FCC themselves came up, calculated that what power each station could run, and it was an individual station because every station had an interference problem. This 250 watt station I built in Valpo on 1080, we had to protect KRLD in Dallas, Texas, and WTHI in over in Hartford, Connecticut. And Hartford, Connecticut was the 1A, and Dallas, Texas was the 1B station. And we had to protect both of them. The FCC has a very strict policy that just not everybody can practice before them. They've got to be qualified and so forth. And, I have filed many, many reports with the FCC, but I can only go so high. I cannot apply for a news station and do the engineering for it. None of you guys could, I guess, either. You got to be qualified, and they got to take you through the blueberry patch to see if you're qualified, and then you become a member of the FCCE, Federal Communications Consulting Engineers. In the same way with attorneys. Only certain attorneys are allowed to practice before the FCC. So you get your tail in trouble. You can't take your Gary attorney to Washington. They won't let him even in the door. You've got to hire Dow, Lomas and Albertson or somebody else at $10,000 an hour and so forth. And that brings up, for the application then on this station in Valpo, for example, we had a consulting engineer, Ed Jacker, over in Lombard, Illinois, who's dead now. He did all the engineering, did all the fighting to get the license for us and so on. This PSRA law came in, and Ed Jacker says, I don't want to go to Washington and do that. I'm semi-retired, he says. I get my old buddies, Lonas and Culver, and Culver and Loners, I guess it was. And no, it was Lonas and Culver. And he said, they're good, they're qualified and so on. So I called over to Washington and got a hold of George Lonas, and he said, okay, I'll let Betty Dahlberg, my other consulting engineer, do the engineering work on it. And in the process, little side story there, I was with a station out in Ohio owned by a newspaper, and the heirs were three sons of the newspaper owners. The parents were dead and they inherited the station, and we had Jansky and Bailey in Washington DC as our consulting engineers, and we had Dow, Lonas and Albertson as our attorneys. And my boss always made it clear, don't you ever get anybody except Lonas at Dow, Lonas and Albertson, because he's our cousin. And so I left there, and centuries go by, and I hear 1970s or 70s, I guess it was, I come in contact with George Lonas over at Lonas and Culver Consulting Engineers. So I talking to him, and I said, by the way, George, I said, are you any relation to Lonas over at Dow, Lonas and Albertson law firm? He said, oh yeah, he said, that's my feeble-minded brother. He said, my other brother and I were consulting engineers in electronics, and he said this one was feeble-minded and he went into law. So anyway, continuing on with that story, Betty Dahlberg was she was a qualified radio engineer, accepted. She was a member of the FCCE, and she did the calculations on our PSRA in Valparaiso for meeting the qualifications of not interfering with, or limiting the interference to KRLD and WTHI and Hartford. Hartford said no interference. They were protected from no interference. So we had to protect Dallas. Here's a map that Betty Dahlberg drew up. Here is our 25 microvolt per meter contour, and we just crossed Memphis, Tennessee. Here's Dallas's 50 kW coming into Dallas and back out, and they're protecting Hartford by having a null in this direction. So anyway, to meet these specifications, Betty Dahlberg, she told me on the phone, says, I calculated at 9.7 watts. He said, let's just apply to the FCC for 10 watts. Fine. So we got to drop our power from 250 down to 10 watts. So we built a power divider, which I want to get into next, but let me continue this story. We went ahead and set the power divider for 10 watts, notified the FCC we were running 10 watts from 6 a.m. to our normal sign-on time, which was around 7:15 or something like that. And got everything except what I need.
Did the 10 watts cover the Valpo area?
Yeah. On the Valpo Tech, on the internet, some of the guys got onto this subject here recently, and so one of them quotes that we were heard in Michigan City on 10 watts. I never heard that. I did personally check it, that we had a good signal up on Route 6 north of town. Our consulting engineer come back and says, well, you should get to Washington Street in Valparaiso if the wind's blowing strong enough. So at any rate, Betty Dahlberg calculated 9.7 watts. And she said, well, we'll just go ahead and apply to the FCC for 10 watts, so we did. And I set the power divider for 10 watts. Now, what I'm going to do here in a minute is show you the power divider. What we did was take a 250 watts and dumped 240 watts into a dummy antenna and fed 10 watts to the antenna. Well, we went along for several months. Got a big old official letter from the FCC, said, we made a mistake, your consultants made a mistake, you can only run 9.7 watts, which is what Betty Dahlberg had calculated in the first place. So I reset the power divider, just tweaked the capacitor a little bit. Now we're running at 10 watts, we're running 224 milliamperes at the antenna instead of 1.5 amps that we normally run. So went along for a while, running 9.7 watts. Get a letter from the FCC. We made a mistake in our calculations. You can only run 9.4 watts. Okay, so I
Eventually they're gonna get it
tweaked
right.
the antenna, the power divider, down to 217 milliamperes, sent them an official letter that it's all set and everything's running and so on. Go along for 6 months, another letter from the FCC. We made another mistake in your calculation of field strength. You can only run 9.1 watt. 213 milliamperes for me as an antenna, so I tweak it down. As I say, that arm of the power divider was a variable capacitor, so it's just a case of tweaking it down. And I notify the FCC officially through our attorneys in Washington that I've cut the power back to 9 point, and we stayed that way. Then the Daytimers Association thought, well, if we got away with that now, we've convinced the FCC that we need time in the morning. Valpo went off the air at 4:15 in the afternoon in December and January at sundown. So the Daytimers Association went back to the FCC and tried to get post-sunset authorization. And so they finally got it through, and the FCC come out with a stepped power, and our post-sunset started at 30 watts, and it dropped, no, it went up to 37, went up to 45, and so forth. And I had no way of building a power divider that the announcers could switch and do that, so we just stayed with the 9.1 watt, or 9.1 watts in the evening. And you don't have any listeners in the evening anyway, they're all watching TV, and so AM is useless in the evening. So at any rate, unlike what we might do as hams, cutting a 250 water back to 10 watts, just uncoupling it and so forth on sideband, I guess you could do that because you're running a linear amplifier, but on AM, you can't mess around with the power too much, otherwise you screw up your modulation and so forth. So as I say, we just run the transmitter at 250 watts. And besides, you just got announcers here that are doing this switching. And they know nothing about technical stuff and everything. You just give them meter readings that you gotta have and do this and do that. So any rate, show you what came out of all of this, and play with your mind a little bit. Go ahead.
Hey Marv, I wonder if the people from the FCC, they kept lowering their value, if they were Purdue graduates.
I wouldn't doubt
Could
it.
be.
That's what I'm thinking.
Did you ever measure the reception difference between 9.1 and 9.7?
No, you couldn't tell it. Fade would overtake that and so on. And I had no official field strength meter to even begin to measure it. That brings up another story. WIND used to be down at Black Oak years ago until the kids found their ground system and pulled all of it up, and they, instead of planting a new one, they moved the whole site. Any of you know Kenny Shirk when he was chief engineer there? Kenny was a good friend of mine that I didn't see very often, but he had he blew a modulation transformer on the transmitter, and incidentally he had two 5 kW transmitters, an RCA 5F and a 5M, and they were quite similar, not very much variation in them. And he blew a modulation transformer. Well, back up, when I first went to Tech, I had a roommate and a buddy from Broken Sword, Ohio, just outside of Bucyrus. And after we all survived World War II, and he ended up with, eventually with Group W, Westinghouse. And WIND was a part of Group W, with WOWO in Fort Wayne, KDKA Pittsburgh, and WBZ Boston. And my ex-roommate was director of engineering for that whole group. And so he's on the telephone harassing Ken Shirk about blowing a modulation transformer, letting it overmodulate. And I should have got on the phone and read the riot act to Glenn, but I didn't. And so anyway, I took a general radio bridge over. Kenny had pretty well proven that he had a shorted turn in the one half of the modulation transformer. And so he called me and wanted me to bring a general radio impedance bridge over, and I took it over and we measured the transformer. He had it out of the cabinet. It was a big, tall thing, 3 kW, or about 5 kW of audio out of that thing. And of course he had the standby transmitter. They had these two transmitters. They ran one of them 24 hours a day until Sunday night in the middle of the night. Then they were off the air for 3 hours and made the switch over. Of course they'd switch over instantaneously, but they did maintenance for 3 hours and then put the other transmitter on. So he's not off the air. So anyway, I measured the modulation transformer, and 80 henries inductance on one half and 60 millihenries on the other half, which was a shorted turn. So at any rate, Kenny was a perfectionist, and in the 3 hours that they were off the air, the guys had to take Von Amy and polish the copper tubing in the coils and the matching networks and so on. And I just happened, I was talking to Kenny, and I just happened to lean up against the 5F like this. And Kenny says, "I would appreciate it if you didn't put your hands on my transmitter." And I take it down, and he gets his handkerchief out and polishes them up. The guys on their maintenance, when they were out there, they put auto wax on the transmitter cabinets and all the equipment in that room and so on. But Kenny was very nice about it. You didn't leave fingerprints on any of his equipment. It was, you talk about maintaining a broadcast station, he maintained it. And to think of some of the junk that's going on now, that they don't even take the dust out of it or anything. So at any rate, the power divider that we ended up with Well, I let that one sit out in the sun 2 months. Well, actually, this part here was out at the tower. And we had a T-network in there to present 50 ohms, but the tower was actually 200 ohms tall impedance. So we had a matching network to produce 50 ohms, and that was this resistor here. This is what we call a quadrature power divider. In this case, we have 10 watts here and 240 watts dissipated into the dummy antenna. At this point, we would call this the common point, and here's our common point current, and this is 50 ohms looking in. We have formulas for this, and we calculate in these two impedances in parallel equals 50 ohms. So for 250 watts, I need 2.24 amps of common point current, and put meters in there, and that all worked. For the antenna, for the power divider here, we had 0.447 amps, and for the dummy antenna, we had 2.19 amps. And these are all metered, and this is all submitted to the FCC and all the engineering data behind it and so on. Look what happens. Here's 2.19 amps, and here's 0.447 amps. At this point, we should have 2.63 amps, but we only got 2.24 amps. What's going on, Marv? This current here is at an angle of plus 78.4 degrees. This current here is at an angle of minus 11.3 degrees. This is at an angle of 90 degrees, 2.4 at 0 degrees. It's getting into vector algebra and so on, but when you add these one current is up here and the other one is down here, and when you draw the thing, you end up with this 2.24 amps. And if you notice the angles here, 78.4 plus and minus 11.3, we got 7, 9, 89.7, that's 90 degrees, what it's trying to tell us. So you got, this is what we call a quadrature power divider. And we build our own. Companies sell these things. They'll design them for your particular installation and so on, but we built our own and and unfortunately I didn't get my hands on it when they sold the station out and so on. I wanted to grab that thing, but because the buyer just jumped junked all the equipment. And the transmitter I have down in Plymouth now, and the console, Danny Sheets has that over at his tower in LaPorte, and so it never left the area here. Okay,
Can I ask a quick question?
yeah.
How did you get the phase angles like that without any capacitance?
We've got capacitance here.
Oh, but I didn't see it.
And this
Okay.
inductor
The
here.
inductor I see, but I'd say, well, there's no capacitance.
And we set these up on, we have equations to calculate these
Mm-hmm.
things, and so this was just a little rotary coil, no dial on it, you just reach in and rotate it and hope that you didn't burn your fingers. We hadn't, after once set it up, you don't have any reason to readjust it, except when the FCC notifies you that they've miscalculated by a tenth of a watt or something.
Policy defies common sense.
Gene, my question has to be, if you just wrote them a letter back saying, yeah, we readjusted it and didn't, do you think they'd really know?
I doubt it. And today, I don't know whether they even got any inspectors on the road or not.
Yeah.
Lawyers, we got lawyers.
Well, they got lawyers. You better believe they got lawyers. From a ham standpoint, if you guys go back far enough, you remember when Riley Hollinsworth took over as the enforcement chief, and he was a ham. And when he took over, he says, I'm gonna clean up the ham bands, and he said, my first job is to clean up 14313. And 14313 was just rampant in those days. WA4 Dog over in Virginia was one of the ringleaders on there, and they just feuded on there day and night, and the awful language and so forth. And by God, he cleaned up 313. He cleaned up the rest of the band. You had WHCH up on 75, 3865. They finally nailed him, and Riley didn't put him off the air. He just put him off 75 meters after all of his foul language and so forth. And then I feel sorry for the guy. He lived in a little burg, outside a little burg in West Virginia, and his house caught on fire and burned to the ground. He lost everything. I haven't heard of him for years. The house burned 3-4 years ago, and I haven't heard him back on the air or anything. I don't know what happened to him. He was a merchant mariner, electronics man, worked in the merchant marine. He'd be gone for 6 or 9 months and then home for 6 months until his name came up again. And he was drunk all the time when he was home. And so his wife owns a dental laboratory, dental surgery laboratory in another town. And so, but I haven't heard of him, but he was lucky that they didn't take his license away for all the profanity that he used to pull on it. Now we have a woman lawyer that doesn't know a ham radio from a cane. She doesn't have the slightest idea what ham radio is about, and she's in the enforcement branch, and so she'll go strictly by the letter of the law and have no idea why she's sentencing this guy to 6 months in prison for operating CW on a single sideband frequency. That technical talk would mean nothing to her, so it's going to be interesting. And anyway, 14313 is coming back up, and it is starting to have a bunch of rabble-rousers and profanity and arguing and fighting. And there's another one going on 7213 in the mornings that they're going to have to set on, and so on. So it's going to be interesting. So at any rate, I was supposed to talk about antennas, so let's see if we can get into a little bit of it. And I didn't pay any attention to what time. Marv said I had 15 minutes here to talk. So,
You've never done anything in 15 minutes.
What is that power ratio of 9.7 watts to 9.1? Is it like A
Jeez,
tenth of a dB?
I don't know, I got a calculator, you wanna calculate it out?
I don't know how to use a calculator.
dB, what's that?
Dumbbells.
Oh. Ed's one of my former students. What have I
You
got?
playing
How many-
Ed?
How many form, 1, 2,
3
3?
at least.
Jack McCarty here? Yeah.
62. Still got that 30D?
No, I dismantled that thing about, what was last winter. I took it all apart and I threw everything away except the microphone transformer, so I want to play with it. I notified your editor here on your newspaper, the commercial services on December 31st of next year, or January the 1st, 2013, they have to cut back on their modulation, their FM deviation from 5 kc to 2.5 kc. And so there's many of the two-way radios, we're talking commercial FM, police and police and commercial services. Many of the radios that have been built in the last several years are capable of going into the split channel, both from the selectivity of the receiver and the cutting down the deviation and so forth. Otherwise, if they don't have any adjacent channel, a 15-year-old or 20-year-old radio can be cut back to 2.5 kc and meet specs all right. But at any rate, if any of you remember, in 1960 we cut back from 15 kc back to 5, called the split channel regulations, and this one is called the split channel. And now I see in the press that in 2030, which I don't expect to be around that late, they're having another split channel. I don't know what that's all, but I haven't read about that at all. But at any rate, the dealers, you might say, the two-way guys that install and sell equipment, of course, they want to sell new radios. I have a graduate down in central Illinois selling a line of, well, he's selling what used to be the Yaesu line, which Motorola bought, they call it Vertex. And most of his customers are choosing to buy new equipment because most of them are, he has a lot of farm and co-ops and so on. And most of his customers are buying new equipment. Plus, I had at school 4 brothers, one after another, one and then 2 at the same time, from Cumberland, Kentucky. Their father was Green Cornett. That was his name. The Cornett brothers. 3 of them are still living, and all 4 of them ended up at Motorola in one form or another. And so at any rate, I've been in contact with them over the years, and just recently, Tom down in Cumberland, Kentucky, who has a Motorola service center, sent me a radio that they'd taken out of service and sold him a new narrowband radio. So I have a solid state. I'm up to date, boy. I got solid state. And the guy in Central Illinois is sending me up another one for a standby. When he gets one, he hasn't gotten into them too much yet. But it's going to be interesting to see what this narrowbanding all is. And I see for the first time, yesterday's newspaper had an article on the Porter County Sheriff's Department. And they've been into a hassle for the last couple years on their 911 center, and fired the director on it and hired a new guy in. And it's just a bunch of turmoil down there. And at any rate, this is the first article that I've seen. I understood that there was an outfit in Lake County that leased the radios to them for their entire sheriff repeater system. And I presume you know who I'm talking about. And anyway, there's an article yesterday that the commissioners got hit Tuesday at their normal monthly meeting with a proposal with the information that it's gonna cost them 20 to $40 million to update their radio system by December of next year. I can't see that, but I thought Minor was leasing the radios to them, that would be taken care of in the lease. So I don't know what that article's all about, but I'll have to talk to Joel and see what they plan on doing. But anyway, there should be lots of used Motorola radios available, and John Giannotti can get a new GM 300 from somewhere. that
A
works.
new one, my GM 300 is probably 20-some years old.
Well, I mean, one that works.
I got one that works. One doesn't, but I still got one left.
Oh, you still got one?
I still have one left that works.
Okay. Okay, well, how many minutes I got left?
You got 15 more minutes.
Okay.
14, 12.
Well, if I run over, you just get up and walk out.
That'll never happen. We learned our lesson.
You did say it was a quiz, right, at the end?
Yeah.
Quiz, I forgot.
I think last time I remember walking out in class, we got a test while we walked out.
I used to be kind of a stickler for attendance and so forth.
Used to be.
And, the Valpo Tech Alumni Association are on internet. They have their own thing. And once they found out I was on there listening, they've been kind of riding me about some of the things that I did. And I ruled with an iron hand. I didn't make sergeant, but I ruled as an old sergeant, and I didn't take much guff from the students. And one of the things that I was kind of insistent on was being in class on time. And my boss usually tried to arrange my classes so that I had the room next to my office and I had a private door through it. And so when the bell rang at 8 o'clock, I locked the main door, and so they'd cut through my office, so I had to lock both doors. So these guys have been on the computer telling me stories about how I would lock the doors on them. So, incidentally, I'm full of stories tonight. Had a student that I don't know much about him, but he was kind of a troublemaker in the class. And my office and my main classroom was a half, I guess, what was 27, room 27, 10 feet off the ground from the window.
Something like that, yeah.
At any rate, this kid was causing so much trouble that during the noon, we had a class break from 11:50 to 12:20 was a half hour. Otherwise, it was 10 minutes between classes, and we had that half hour, which was usually a faculty meeting and so on. At any rate, they got into a scuffle, and they just opened the window and they threw him out the window. He dropped about 10 feet. I knew nothing, I heard nothing, I saw nothing, I didn't have the slightest idea what happened. Had another kid that irritated the class when we gave a test. He would sit at his desk and he'd run his fingers like this and then write something. And he'd just drive the people around him nuts. He had a book, he had a satchel that he carried his books in. So they got to stealing his bookcase. So he'd put it right beside his seat and so on. If he went out, or after the class started, they'd slide it. No, they'd pick it up and pass it from one to another. They'd put it back in the back of the room or something. So what's he do? He puts a pressure switch in the bottom of his bookcase. He's a pretty sharp kid, so they lifted up, the bell rang. Well, they started to slide it. Well, he put a motion detector. So I guess that's where it ended up. He tied his book satchel to his desk or something with a string or something. We had a lot of fun and a lot of sadness and so forth.
Well, at least he was learning.
Yeah, he was a good kid. Otherwise, he just was kind of obnoxious with his hand stuff. At any rate, let's get back to an antenna here. A basic antenna is a half wave long, and a wavelength in meters is 300 over frequency in megacycles. So, 80 meters, you divide 80 into 300, you get 75, so 75 meter band. Or if we multiply this by 3.28, we get 984 over the frequency in megacycles is the half wave in feet. A half wave is a self-resonant antenna, as you all know. But if we set this half wave wire up and feed energy to it, we have corona and other effects, capacity effects, because it's a high impedance to ground and so on, of about 2.5% of the length of that antenna on each end. So to make the thing self-resonant, we got to chop the physical, the metal part of the antenna back. So a half-wave antenna in feet is going to be 468, half of 492 over the frequency in megacycles times 95%, or 0.95. We gotta take off 2.5%, 5% total off the length of it. So this ends up giving us a half-wave antenna in feet, is our old familiar 468 over frequency in megacycles. Well, we may want to go longer than that. I don't have time to go into much of an explanation, but if we take a transmission line and make it a half wave long, we repeat whatever the load is out here. If we make it a quarter wave, we invert whatever RL is. In other words, if this is high, this is low. If this is an open, this is a short. If it's a capacitor, it's an inductor, and so on. I'm going to use here the half wave, that whatever's out here, we repeat it, any number of half waves, and this is any odd number of quarter waves inverts. So let's take a wire and let's make it a full wave. Better add a little over here. This is a half wave, and this is a half wave. We will have voltage on here like so. Now this is one continuous wire. We're not broken in the middle. One continuous wire. If we take a half wave, we have a radiation pattern that is a familiar donut pattern, broadside to the antenna. Last summer we had a VHF contest, and of course with Channel 2 in Valpo in this area, we had a strict law that no students or faculty operated 6 or 10 meters, because you just took the city out, and we had a public relations problem that was. So now with everybody on cable and with Channel 2 down the drain, like even I have gotten on 6 a little bit, and we had a VHF contest during the summer, and fortunately we had a tropo opening. And they hardly ever coincide, but we had a tropo opening, and I worked from the west coast to the east coast. And so I heard a guy working the east coast something, and I was just listening to him, and he says, "I'm in Gary, Indiana." And my caller, W9LIO, I'm using one element directional beam. And I thought, what in the hell is Lionel trying to pull now? So he, in the same breath, he says, I have a dipole that I rotate. So, but he was passing this off as a one element directional beam. Well, a few weeks later, I contacted him on 6, and I said, Lionel, what's this thing about a one element beam? And he started laughing. He couldn't stop laughing. He said, I pull that on those guys, and they think I got something invented out here new. He said, all I got is a dipole, and I rotate. I've never met Lionel, but he seems like a nice guy on the air. At any rate, him and his one element rotary beam. If we go out here to a receiver, look what we got. A plus minus and a minus plus field coming at us. We get 0 voltage pickup or radiated. If we started a string or started walking around here, there's going to be somewhere around here where this distance here and this distance here are the most out of phase that they can get. So we will have some in phase voltage. So it ends up with this antenna, we end up with a 4-leaf clover like so. If we add more, we get more here, and just, I don't want to dwell on that, but if we take a random, if you know the wavelength, what we have for a pattern of course this is on both sides, but looking here, here we don't have a major lobe perpendicular to the antenna. Here we do, so I got one. Here's a five half waves. For a long wire antenna, you get as many lobes as you'd have half waves in the antenna. So this would be a 5 half waves. A 6 half wave would be 3, and a null and perpendicular to it. So you can guess on what you're going to have. Well, let's take this idea a little further. Here's a half wave and another half wave, and let's say that the current is going this direction, and this is the opposite phase, so the current is going to be going the opposite direction. Well, you've all heard of it. Somewhere in history, we had dirigibles or zeppelins. They needed radio communications on them. And of course, in the day of the dirigible, you didn't have any frequencies above 30 megacycles, and this had to be long distance anyway. So they were using 1.5, 2, 3 megacycles and using a trailing antenna. Well, unfortunately, the trailing antenna was this particular length. My scale was kind of out kilter here, but the antenna was so close to the body and flying around, it caused the signal to go up and down and so on. So somebody conceived the idea, let's take this thing here and take this A section compared to the B section, and let's fold that A section down on itself. And so here's point 1, point 3, and here's point 2. Let's fold it back to itself. Here's a quarter wave stub, and see the current's going from 1 to 2 to 3. We got 2 wires parallel with current going in opposite directions, no radiation. So we'll tie the antenna on it just like up here. And here we'll do that same thing down here. We'll feed the stub and there's the trailing antenna hanging back. We'll use open wire line because of the low losses and so forth. Here is the ZEP antenna. Now we can do the same thing, center feed with open wire line, and it's incorrect, but you get the point across. Guys will tell you they're using a center fed ZEP. There ain't no such animal. The ZEP indicates that you're using open wire line to feed it. And so I guess it gets the point across that, okay, I'm using a center fed ZEP. You automatically know I'm using whatever length the flat top is and fed with open wire line and so on. So let's get into multiple wavelengths. Let's say we wanted to build an antenna 3 half waves. We only got 2 ends here to take off 5%. So this is not quite correct, that I can't calculate a half wave for the center section there because it doesn't have ends out here. So we have to modify this equation that the length of the antenna is going to be equal to 492 times the number of half waves minus 5%, all over frequency and megacycles. And this will give us the correct length for the long wire if you want it to stay resonant and so on. Okay, let's end up here with let's take 3 half waves and let's go to 14.23 megacycles, middle of 20 meter band. Calculating that out, we're going to come out with 102 feet overall, from one end to the other. Let's see, we got center. Let's open up the center and feed in here, and we're going to be a low impedance, and so let's. Walt Maxwell tells us this is about 90 ohms plus a little reactance of a little bit here, but basically 90 ohms of resistance. Let's put a half wave line in here. And so we will repeat the 90 ohms down here. We could put in here, I got myself cramped in here. Let's put a resonant circuit in here and link couple it. And tie that. That's an awful sloppy diagram. But let's use a parallel resonant circuit that tuned to 14.23 and match from here through coupled circuit theory to 90 ohms or so. And you're in business. A good friend of mine, Bruce Balsley, if any of you know him, W9OTN, south of Valpo, has a 200-foot antenna, center fed with open wire line, and he has no idea how long his line is, and it doesn't make any difference. And that brings up another story. Abraham Lincoln practiced law in in Illinois, and as you know, he was very tall, and in those days, his transportation was a horse, and he would go into a county and hear all the cases that were pending, settle them all out, send everybody to jail, and get on his horse and ride to the next county and hold court for as many days as necessary and so on. And being so long-legged, he got to be the butt of a joke, particularly the kids. And they would kid him about his feet almost dragging the ground, and why didn't he get off and let the horse ride for a while and so forth. And finally, one day, somebody asked him, said, well, Mr. Lincoln, you do have quite long legs. Said, how long should a man's legs actually be? And he said, well, I reckon they should be long enough to reach from his ass to the ground. That's the same way with ham antennas or any commercial antennas. How long should the transmission line be? Long enough to reach from the antenna to the operating position. Don't worry about it. Well, Bruce, being a perfectionist, and he is a perfectionist first class, he works 160, 80, and 40, particularly on his 200-foot center fed with random length feed line. He has no idea how long it is, has no interest in it, but when he tied it onto his, if he resonated this circuit and then tied the transmission line on, he had to retune it. He didn't like that. So he goes in for all bands that he operated, and he determined how much reactance he had here, and actually put a rotary coil or a capacitor across there, so that all antennas, he tunes his tuner to resonance and puts the antenna on it, and there's no change in tuning, which is a good idea.
And he has a circuit for each band.
Yeah,
All
and
lined up.
he uses separate tuners. As I say,
Pretty
he's
impressive.
he's a perfectionist, and so. And that reminds me, I got a Johnson matchbox. If anybody's interested in buying one, it's a 250 watt job. I want to get rid of it. Well, without going into it, let's take this 3 halfways on 20 meters, and let's put it on 160. What am I going to have? A chunk of wire fed with a chunk of transmission line, and God only knows what impedances I have. Let's put it on 80 meters. The same situation. It's a random wire fed with a random length of transmission line, and you're going to have to tune it. But somebody, which you all know who it is, comes out with the idea, let's put a balun in here. And that's a balun, not a balun. A balun.
Amen.
1-to-1 impedance ratio. The 90 ohms shows up here as 90 ohms. Let's feed RG8 over to that. And make it a random length, but you can make it a resonant length if you want to. And so the Z input here is going to be a little bit questionable, but it should be about a 2-to-1 SWR here. What's the antenna?
G5
5RV.
G5RV.
Yeah.
How in the world this thing became so popular and everybody gets the idea that it's God's answer to an all-band antenna? It is nothing but a chunk of wire hanging up there on anything except 20 meters, and even Varney, that invented it or built it up first, admits that it's not designed for any other band except 20 meters. It's a 20-meter, 3 half-wave long wire. But I don't know, the word got out that it worked on all bands, and you just tune the bands, and within 3 minutes you'll hear somebody arguing about, gee, I just can't get this thing to load on 80 meters, it just won't do it without a tuner. It's supposed to be matched on all bands. There's no way it can. Well, after upsetting all your good feelings about G5 RVs, thanks, nice talking to you.
Thank you.